Welcome back to class of our training section. Today we are completing our training and see your instructor. We are dealing with Chi-sqaure and reliability test. Chi-sqaure and reliability test. Okay. Let's say this is my data. I've entered and I want to run Chi-sqaure. What are the steps? We go to analyze. After that one, you navigate down to non-parametric test. Non-parametric test. Can you see it? Then you navigate to Chi-sqaure. Chi-sqaure. Click on it. Now this is another test box. Then under at the top we have Chi-sqaure test. You select your variable. Let me just select these two variables, import and export. You click this arrow key to go to now. You see now it has gone to test variable list. Then you come back to the upper right corner here. You click on exact. Now exact test, you see as asymptotic only or Monte Carlo. Then I want only asymptotic and I'll click continue. You go to options. Now under this, as do you want any descriptive analysis to appear for you? Yes, I need descriptive. I click OK. If you want quartile, click this. Then there's nothing, it's excluded cases test by test. Click OK. Alright. After that, you see this place, expected range, get from the data. Expected value, all the category are equal. You click on OK. These are test results. You see now this statistics that you click on, that's it. The number of observation is 35. The mean of import is this. The mean of exports is this. The standard deviation of import is this. The minimum value of import is 5.9840. Why the maximum? Because I click on descriptive statistics. These are frequencies of the variable enter for import. Yes, to 35. And for export 2, I have it here. Observe and expected. I have it here. Okay, look at our Chi-sqaure analysis now. Look at it here. Chi-sqaure here is giving me what? 0.00. Why? The reason is that here, look at it now, I don't have any degree of freedom 34. My associate significance is 1 and it must less than 0.05. Why do I have this one? Because under Chi-sqaure you must have observe and expected. Observe minus expected. I look at my observe here, 1, expected 1. 1 minus 1 give me 0. Therefore I can't get any answer. If you go to this one too, my observed number is 1, expected number is 1, and 1 minus 1, the residue is 0. Therefore that is why I have the value of my 36. Under import is 0 and under export is 0. Can you see it now? Now let's get another one and see. Okay, let's look at this now. Go to under analyze. You click on non-parametric test. You click on Chi-sqaure. Let me use math test. See math and English achievement test. I click OK. I click on exact. Yes, assorted. Yes. I click option. I want descriptive. Yes. I click OK. I click OK. Now my mean, the number of observation here now is 60, the mean and everything. The mathematical achievement test, the one I have, yes, and English. Now look at now my chi-square here now. Now under maths, you see the observed number 12 is 7. Expected is now 7.5. The difference is this minus 0.5. You see now, since I have number here, I can get my chi-square. For the first one, we have 0, 0. We have 0, 0. See this side now. 0, 0, 0, 0. That's what I have. You see, 0, 0. So the residual there is 0. See now. Therefore, once I have 0 here, I can't get any value for chi-square. But look at this recent one. Look at this. Here now, I have positive, I have negative. Look at the difference here. Look at the difference here. For mathematical achievement test. And now the degree of freedom under mathematical achievement is 9. The associative significance is 0.1. But look at my chi-square now, the value now. This is now, and you see the frequency is less than 5. The minimum expected and frequency is 6.0. And see my English achievement test, I have it as 3.469, not 0 again. These are taking, and I have my asymptotic significance, which is 0.839. I have it, and unlike the other one that I have 1.00, because there's no significant, there's no difference between that expected and observed value. That's how to run chi-square. Now after that, you now go to your 4-figure table. Although with this one now, it is not significant. You go to your 4-figure table, chi-square calculated, chi-square tabulated. This one is calculated. The one you check in your 4-figure table is tabulated. You now check under the degree of freedom of 9. What do you have in that 4-figure table and what you have here? If what you have in 4-figure table is more than this, you will now, it now depends on your hypothesis, whether to reject the hypothesis or to accept the hypothesis. Likewise, this, you check the value you have here, which is 3.4. Under the degree of freedom, this is the calculated. You now put your 4-figure table to chi-square table, the place. You check this degree of freedom of 7. You now check the value that you have. If the value you have is greater than this one, you now reject the hypothesis, whether there's a relationship between English, there's a relationship between performance of students in the English test and their behavior. Now, if that one is greater than this 3.4, you say there's no relationship. That's how to run chi-square analysis. Now, let's quickly move down to the second and the last one, which is a reliability test. Now, the reliability test is talking about when you want to administer your questionnaire. The first thing you should do is to prepare your questionnaire and check whether the test you want to administer is valid or reliable. Now, the question, you first administer it to some people, then you collate the results, analyze it, and see their response, whether their result is reliable or not. How do we analyze that? We go to the analyze. We go to scale. You see it now. We navigate to reliability analysis. Reliability analysis. Click on it. What are the tests I want to analyze? Now, I want to analyze this mathematics and English achievement test. I clicked on that item. What do I want under this item? This pause. You click it. I want descriptive for what? Item scale. Now, do I need item correlation? No. ANOVA, I said I don't want. Do I have a F test? ANOVA table. If I have this, what I will click. If I need F test statistics, click on it. Under this now, under the summary, do I need variance? Do I need mean? Do I need variance? Yes. then descriptive for what? For items. Click continue. Then you come back to display scale, because we have different methods you can use. We have alpha, we have split up, we have Gotma, we have parallel, and we always use split up. What this split up means is that the questionnaire, either you administer it, the same questionnaire, you administer to a set of people 2 times, you now divide it, so that if the result that they fill in for the first time is the same thing with the result that they fill the second time, you say they know what they are doing, they are reliable. So I think when you click on OK. And these are the test variables. 60, that's the test variable. Okay, let's see. This one item, the items are the one I click, the mean, the standard deviation, which is also the same thing with what we have done. Okay, part 1, part 2, both for items. I said they should give me the summary of the items. The part 1, I said split up. See, split up 1, split up 2, then both item variance to split up 1, split up 2, both. This is what I have now. Range is what I have here, the maximum, the range, and the minimum. ANOVA, I click on ANOVA table too. Look at this ANOVA table. This ANOVA table for that split up. This is now the summary of the squares within the people, within the item, the mean square, the F36. Therefore, the global alpha that we have here, now come back to this place. Global alpha results, total correlation equal, now this is it. Display amount correlation, the global alpha part 1, part 2, then the part 1, number of the value and everything. What is now our value? This is our value. This is 0.161, and actually supposed to close to around 60-70 above. With this now is telling me that this state I'm going to administer for first and second time is not reliable with this result. Look at it here. It's not reliable at all. That's what the test is talking about. And even we can get that one from this place. From the F statistics I put in, see, the F statistics I put in is telling me that CO, my significance is 0.483, and anything greater than 0.05, it is not significant. It means that the test, the reliability test here, reliability test, this reliability test here is that the items I want to use is not reliable at that moment. That's what the result is telling me with this value, correlation between the form equivalent is 0.9 and this one. Assuming that this one is almost, when you multiply this one by 100, you get that. Multiply this one by 100, you get 16.7. This one to 16.7 and this one 16.1. And 16.1, if somebody scored 16 out of 100, the person is not did not pass the test. That's what this result is talking about. Is that taking?